Review of probability test question number 2. Question 2 says if the probability of A equals 0.24 and the probability of B equals 0.52 and the events A and B are independent, what is the probability of A or B? Okay, first we're asked to find the probability of A or B, which in symbols is the probability of A union B. So let's go to our formula sheet and we see that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of their intersection. Because when we count everything that's in A and everything that's in B, we've counted the intersection twice and we only want to count it once. So we have to subtract it out once. Okay. So write out the formula from the formula sheet and fill in what you know. We know that we were given the probability of A was 0.25. We were given the probability of B was 0.52. What about the probability of A and B? Well, we could go back to the formula sheet and we see the probability of A and B in this formula here and in this formula here. Well, we can't use this one to solve for it because we don't have the probability of A or B. That's what we're trying to solve for. If we wanted to use this formula and solve for it, we'd have to know the probability of A given B. But let's look at that a second. Okay, so we wrote out our formula. So we know that the probability of A given B is the probability of both A and B occurring over the probability of B occurring. If I rearrange that to solve for the probability of A and B, I get the probability that B occurs times the probability that A occurs given that I know what happened in B, which I don't know that. So I don't have the probability of A given B. But wait a second. Let's go back up to what they told us. They said events A and B are independent. So if events A and B are independent, then the probability of A given B, if they're independent, then B doesn't give me any additional information. So then that's just equal to the probability of A times B, which we were given, 0.24 times 0.52. So the probability of their intersection is 0.1248. So back to our original calculation, the probability of A or B equals the probability of A, 0.25, plus the probability of B, 0.52, minus the probability of their intersection. This is their answer. Did I have to go and rearrange this whole formula? Well, not if I read carefully, and if I read that they're independent, and I know if two events A and B are independent, then the probability of A and B both occurring, or just the probability of A times the probability of B. So our answer is 0.6352, or letter C.